This is U8F1-V's video 2 on factoring trinomials. When we look at a trinomial like this, 3x squared plus 13x minus 10, in order to factor this, we need to do a little bit of pre-work here. And I'm just going to do this by using a table. We are going to want to take the A term, which is 3, the A is 3, and we want to multiply it by our C term, which is negative 10, okay? 3 times negative 10 is negative 30, okay? We're gonna factor negative 30, and it has to add up to the B term. The B is 13, positive 13, okay? So we're gonna factor negative 30, and the two factors have to add to the positive 13. Okay, so basically we can start at negative 1 times 30. Negative 1 times 30 is negative 30, but when we add those, that's 29. Okay, so we know that doesn't work. Let's say negative 2. If I did negative 2 times 15, that's negative 30, but adding, that's 13. Oh, so right there, we found our two factors that adds to the positive 13 that we wanted. Okay, so that's just the first step in factoring. Next, we're going to want to rewrite the trinomial. We are going to change this 13x to negative 2x plus 15x, okay? So 13x changed to that. I'm just going to drop everything else down, okay? And now we have our trinomial is now 4 terms. What we're going to do is we're going to factor this by grouping, okay? So we're going to put parentheses around the first 2 terms, and we're going to put parentheses around the second 2 terms. For each pair, we're going to find a greatest common factor, okay? So if I'm thinking, what is something I can divide out 3x squared and negative 2x? I know they both have an x, okay? So I took an x out of that first set of parentheses. Again, when we divide by x, we are subtracting exponents. So we should just have x times 3x minus 2. The second set, the positive 15x and the minus 10, a number that goes into both 15 and 10 is 5. So we're going to take a positive 5 out of that set. It is positive, so we're going to put plus 5 in front. Go ahead and divide. 15 divided by 5 is 3. 3x. I did not take an x out, so the x stays. 3x minus 2. If we do the grouping method right, these two should be the same, and they are. So, to find my final factored answer, we're going to take that 3x minus 2. Okay, it's the same, so we're going to start with that. And we're going to multiply by the outside. So x plus 5 is the second set of parentheses, okay? So my two factors are 3x minus 2 and x minus 5, or x plus 5. Here's another problem. So we're going to start off with our A, C, B table. Again, reminder, the A times C, that's 2 times negative 15, which is negative 30. Again, label if you need to, and B is the number in front, so it's a 1. Factors of negative 30 that add up to 1. Okay, so if you need to start off by starting at 1, you can. Negative 1 times 30. Well, we know that's 29 when we add, so it can't be that. Let's just jump to -3. -3 times 10, that is 7. Can't be that. -5 times 6, that's -30. -5 plus 6 is +1. So we're going to use those two. Again, rewrite our middle term as -5x plus 6x. Drop everything else down. And then we group our pairs. Find the GCF of both pairs. 2x squared minus 5x. You can only take an x since 2 can't go into 5. So that's x outside. Divide, we subtract exponents, so that becomes 2x minus 5. Find something that can divide out of 6 and 5. When we divide, it should also give me 2x minus 5. 6 and 15, 6 and 15, we can divide a 3 out. That is a +3, so we're going to put +3. 6 divided by 3 is 2, so 2x, again, minus 5. Again, those two should be the same. And if they are, you did it right. My final answer, 2x minus 5 is one binomial. And then again, reminder, x plus 3 is the other binomial. X squared minus 7x plus 12. We'll just go ahead and get started here. A times c, again, put a 1 in front, so that's a1, c is 12, 1 times 12 is 12. Adds up to the b term, which is -7. Keep that negative there. Factors of a 12 that add to -7, okay? You have to kind of be logical here. If we're adding two numbers that are negative, but the product of a and c are positive, that means both have to be negative. So just start. -1 times -12 is +12, but if you add, that's -13, so it can't be that. How about -2 times -6? Add, that's -8. We're close, but it can't be that. How about -3 times -4? That's it. -3 plus a -4 is a -7. There's my two numbers. Again, if you want to, if you don't have to show the lines there, if you don't want to, we just know we have to write this in 4 terms. So x squared minus 3x minus 4x plus 12. Okay, go ahead and group, and then we start dividing. What can I take out of an x squared and a -3x? Just an x. Divide, x squared divided by x is x. -3x divided by x is -3. And then the other set. -4x and +12. Again, we're trying to make x minus 3 when we divide. Easy thing is, since it starts with a negative, as I've taught in the past, we're going to have a GCF that's negative. So we're going to divide by a -4, leaving me with x minus 3 as well. Again, they're the same. So we have x minus 3. And then again, those are the same, or the other binomial. X minus 4 makes the other binomial. Last one, 4x squared minus 9. Now, here's what you need to know. This is missing a term. It's actually missing the middle term, because we could think of this as 4x squared plus 0x minus 9. Okay, b is 0 here. Okay, if you want to do a table, A times C and B. A times C is negative 36. B is 0. We're thinking factors of negative 36 that add up to 0. Don't overthink this. It's just negative 6 times 6. Negative 6 plus 6 is 0. Okay? Just remember, this column it's multiplying to get negative 36. This column it adds to get 0. So, rewrite your trinomial. 4x squared minus 6x plus 6x minus 9, and then we group. GCF in that first set, they are both even, so we can take a 2 out and an x. So 2x is out in front. Divide, we get 2x minus 3. Second set, 6x and negative 9. They're both divisible by 3, positive 3. So we're going to take a positive 3 out. And we also get 2x minus 3 when we divide. Okay? So, same thing. They're the same, which we want. We love that. And then those are also going to be a binomial. Okay, so 2x minus 3 is 1. 2x plus 3 is the other. Final thought on this type. Since it was a missing B term, this was a problem that has a shortcut. If you can see the shortcut, excellent. If not, that's okay. Just do it this way as well. All right, guys, you have a good day.